In this video, we're going to work on writing equations from tables. In a previous video, I used these same tables as we tried to find slope. Now we're going to have to find slope and the y-intercept in order to write these equations. And the reason is because we're going to try to write these equations in slope-intercept form. Slope-intercept form, remember, looks like y equals mx plus b, where m is your slope and b is your y-intercept. So I will be revisiting that idea throughout this video with the 4 examples. I'm going to start over here with table number 1. And again, I'm wanting the result to be written in slope-intercept form. So I want to find m, the slope, and b, the y-intercept. Now there are 2 different ways that we found slope this year. One of them was simply trying to find the rate of change and examining the change in x and the change in y. And that is a very good way, an effective way of finding the rate of change, which is also called the slope. However, there are times when that can be a little tricky, when it appears that the change isn't constant, even though it is. And to make it as simple as possible for you guys, I'm going to encourage you, especially if you're watching this video, you obviously need some help anyways. I'm going to encourage you to stick with the slope formula, because the slope formula always works. At least I think in our 8th grade problems we're going to be seeing. So the slope formula, I'm going to draw it over here to the side. It is slope equals y2 minus y1 divided by x2 minus x1. The important thing here is to label your y values and the x values that you plan to use. And it doesn't really matter which ones you pick from the table. So I could select 0 as x1, and 7 as y1, 1 as x2, and 9 as y2. And once I've chosen these values in here, it's just a matter of substituting them into the slope formula up there. So I'm going to do that now. M is equal to 9 minus 7 divided by 1 minus 0. And we get 2 over 1, which equals 2. So our slope is 2. Now, the y-intercept, this is the last thing we have to find to complete our equation, is got to keep one thing in mind. The y-intercept, if you remember from a few weeks back, we learned about x and y-intercepts. The y-intercept is always going to look like 0 for the x-coordinate and some value for y. So with this in mind, the first thing I would suggest is just looking at the values in the table and trying to find where x equals 0. And in this table, it just so happens that we do have an instance where x equals 0. And the y value, this right here, this number, will be our y-intercept. So in this case, it looks like it's going to be 7. So this one is actually pretty simple when you're trying to find the y-intercept. When we put the slope of 2 and the y-intercept of 7 together into our template, we get y equals 2x plus 7. And that is the equation for that table. Now, when we go to table number 2, we'll take the same approach again. I want to write the equation in slope-intercept form, y equals mx plus b. So I'm going to use my slope formula. M is equal to y2 minus y1 over x2 minus x1. And I'm going to again label some numbers that I want to use. Doesn't matter which ones. So I may pick -3 as x1, 5 as y1, -2 as x2, and +2 as y2. And then just substitute these values into the formula. So we have 2 minus 5 divided by -2, and here you got to be careful because the 3 is negative. It's going to look like that, -2 minus -3. So we get -3 on top because 2 minus 5 is -3. And on the bottom, if we add the opposite, we have 2 negatives plus 3 positives, gives us 1 positive, and our slope is -3. I noticed with a lot of the quizzes, some of you really had some trouble using the formula, if you did use it, and using it successfully. There were some just little errors, and it can completely change your result. So we have a slope of -3, and again, for our y-intercept, we're looking for a situation in the table where we have 0 for our x value and some y value. And if we look closely, we see that does occur right here. And again, we want to know what the y value is, and that will be -4. So that means that our y-intercept, b, is going to be equal to -4. So when we take that and our slope and put those together in our template, we get y equals -3x minus 4. And that will be the equation for that table. Moving on down to table number 3. Same strategy here. I'm going to start with the template of the equation, y equals mx plus b, and I'm going to use the slope formula again. Some interesting numbers this time. I'm just going to pick, I may use these near the bottom, so I'm going to have x1, y1, x2, y2, and just substitute those in right here. So that'll be -1 minus -5, and then on the bottom we'll have 5 minus 4. And if we add the opposite on top, we have 1 negative plus 5 positives. That gives me 4 positives. 5 minus 4 is 1. So it looks like our slope is going to be 4. And then for my y-intercept, this is where it gets a little interesting in a table like this. If we try to look for 0y, and we're wanting to know that y value, if we look, we don't actually see where x equals 0 if we examine these numbers, all the way down. But it looks like if we wanted to extend the table upwards, we could end up at 0. So if you ask yourself, well, how are these x values changing as I go backwards? Well, they're decreasing by 1 each time. Decreasing by 1 each time. And then for our y values, you have to ask yourself, well, how are these changing as I go back as well? What I'm trying to do is figure out what is that number that would pair with 0 when x equals 0. So these numbers over here, from -1 to -5, that is a decrease of 4. From -5 to -9, that's a decrease of 4, decrease of 4. So you kind of get the idea here of what's happening. So if I have another decrease of 4, it looks like -17 minus 4 is going to be -21. So that would be my y-intercept. B equals -21. If I put that together with my slope over here, then we get y is equal to 4x minus 21. And that is the equation for that table. So you can see there's quite a bit of work involved here. I'm going to go ahead and do our last one, just for good measure. Same strategy. I'm going to start with the template. It gives me a good starting place. I want to find the slope and y-intercept. I'm going to use my slope formula. I may go ahead and use it down here where I've got some room. We'll choose these x1, y1, x2, y2. And that means I'll have -9 minus -4. And then in the denominator, we'll have -5 minus -6. And if I add the opposite, we get 5 negatives on top. And on the bottom, we get 1 positive. So we have a slope of -5. And then our y-intercept, we're faced with the same thing here. In fact, I'm going to probably have to move some of this. If you didn't catch all the slope formula there, you can rewind the video. I'm going to go ahead and just leave my slope right like that. And the reason being is because I don't see where x is 0. My numbers are actually, as I go down, they're increasing. I'm adding 1 each time. So if I were to do that again, we'd have -1. And if I were to add 1 again, I'd have 0. So the idea then is what number would pair up with 0? So I'm going to look at my y values now and ask myself, well, how are these changing over here? So as I'm descending down the table, I'm actually also decreasing. From -4 to -9 is a decrease of 5. from -9 to -14 is a decrease of 5, decrease of 5, decrease of 5. So you get the idea here of what's going on. But here's the thing, I'm going to have to decrease by 5 twice. So -24 minus 5 is -29, and that would pair up with -1. This is why I have to do it twice, because I'm still not where x equals 0. And if I subtract 5 again, then -29 minus 5 is -34. So that appears to be our y-intercept. B equals -34. So if I take that and my slope and substitute those into the template, we have y equals -5x minus 34. And even though these numbers get, pretty small or pretty large, the basic strategy is the same. And there's really no shortcuts on this that you can take. It's just work. You're going to have to really practice at it, and go back and watch some of the examples again if you need to.